If you don't have a piece of paper and you feel left out, you can just put up your hand. Okay. So there's one here on this side as well, please. Thank you. Have they all received the other handouts as well? Have you? What do you need? Have you received anything? Say again. The notepad.
Anyone that needs notes?
Notes. Okay, so just one notepad on the right. Everyone on the left have a exam pad. You did remember your calculators. Good. Good. Everyone all right? Okay. Everyone good. Everyone good. Okay, ready to start. Okay. Good afternoon, ladies and gentlemen. Welcome. It is, I'm almost jittery, almost a little bit nervous. I haven't been in front of a group like this for 3 years. Yeah, it's been too long, Dr. Lombard, it's been too long. My name is Sarah van Greenen, and for those of you that struggle to pronounce, it's actually written there, S van Greenen, but you can really just call me Mr. VG for short. If you've watched some of the videos on the Junior Tux website, now you're putting a face to the name, okay? I'm the guy that, as my friend that's doing our video recordings, always at the end go, cheers, okay, yes. So, welcome, and I hope you're all excited. I see there's a lot of excitement there at the back, some people already starting to lean there. Welcome, and it is good to have you all here, and I hope that you are going to find some value in this session. So in this session, ladies and gentlemen, we are specifically going to tackle mathematics. We are going to tackle not all the content. I mean, it is physically impossible for me to even come close to tackling all the content that we have to study for Maths Paper 1. Remember, today's Maths Paper 1 for 2 hours. We might take a break in between if I feel like I'm getting exhausted. Or otherwise, we're just going to have lots of fun. Okay, for 2 straight hours, mathematics. Okay? So buckle up. I hope you're going to enjoy this. Remember, today it is all about exam preparation. But what I'm going to do in this session is I'm not just going to stand in the front and talk and chalk. I can do it for 2 hours straight, but you might fall asleep. Okay? I'm going to start by just going through some very important things that I've come across in all my years of teaching. Remember the following. You have only at this stage of the journey answered 25% of your final mark for matric maths. The other 75% is still ahead of you. Yeah, I'm seeing a few eyebrows being raised, because remember, the portfolio, your portfolio of evidence, your SPA, only counts a maximum of 25%. Why do I use the word maximum? Because if you in your matric final exam get more than 10% above or below your SPA mark, they can exclude it. So let's say you have 65% for your SPA mark and you get 80% for your final, you can get 80% on your matric report. They completely discard the 65%. But the flip side is also true. If you get 65 for your SPA and you get 40% for your finals, you can get 40% for your finals. Yes? Really, really. Because remember, it is the discretion of the panel in the end that decides, that deals with those kind of issues. Like I know one of my students at a previous school where I worked, he walked in the matric finals with 65%. End of matric, he walked out with 79% average. Now, I know the guy, and I know he didn't get like 89 or 93% for his finals to be able to lift the 65 to 79. They just discarded the 65% SPA. There's hope. But now, it's on you. That's why I am impressed that on most of you, your first Saturday after a really long term, you are here to do maths. Okay? Although I know some of you only came for the perks. Okay? Some of you only came for the nice badges and the cap, to send the selfies to your friends and go, oh, look where I am. This afternoon when you get to the Hotel 224 and you take the selfie and you're like, look, Ma, I made it big. Okay? But that's okay. I'll forgive you for maybe not being overly enthusiastic to do mathematics. But what I've done is on each and every one of you should have gotten a handout. Did all of you get a handout? So the handout is basically the slides, okay, that we just printed out for you guys. So I'm going to give you a little bit of a tip from my side. Make as many notes on the handouts as you can. Please don't be an idiot. I remember that. No, you won't remember it 5 days from now, because some of you can barely remember what you had for breakfast. And now some of you are going, oh. Okay, so let's start with the first slide. This is one of my ultimate life goals that's on this piece of paper. This is all the work you need to cover for Maths Paper 1. Everything. Okay? Some of it you might not recognize. You might realize looking at some of these things, so I forgot about these. But this is, in a nutshell, everything in every chapter you need to cover. Some of it, you're going to look at this and go, I need to study that. I need to study this. And that's crucial. That's where we are now. Remember, you've now had 2 trial exams, 1 in June exam, 1 prelim. Some of you, after the prelims, are going, I still have a bit of polishing. Some of you go, I've got this. But this is, in a nutshell, ladies and gentlemen, all the work you need to cover. Okay? If you see something that comes to mind and it's not on there, please feel free to come to me and I'll gladly put it on there. Okay? This is mostly the ramblings of a mad mind. One day in front of my matric group, I just decided to write down everything that I've seen in exams. So first of all, this content, which is really important, okay, which is really, really, really important. I'm not going to go through that one. That one we're going to look at tomorrow. Okay, that one we're going to look at tomorrow. Euclidean analytical trigonometry and statistics. But we are going today specifically look at Maths Paper 1. Okay, we're just going to look at Maths Paper 1. So when we talk about Maths Paper 1, and I'm going to please say this, what is our end goal? Be honest with me, matriculants, what is our end goal? Who's willing to put their whole reputation on the line? I'm joking. Yes, so what do you say? Get a university mark. Get a university mark. You have a very short-term goal. Okay? I'm saying this with a lot of respect and a lot of love in my heart for you guys, but if that's your end goal, then you are very short-sighted. Now you're like, sir, that's not very nice. Remember, ladies and gentlemen, I want to just open your eyes. By the time you have finished matric, and I'm a Christian, and I read the Bible, and in the Bible it says, if you are blessed, you will live to the ripe age of, who can tell me? Whoa, no, that was Moses. Okay? Who can tell me? To what? I heard it there at the back. 70. If you are blessed enough, you'll live to the age of 70 years old. Okay? But ladies and gents, if I have this piece of paper in front of me being your life, from born to, let's make it 72, you'll understand why I say 72. By the time you finished matric, you have only lived that part of your life. You still have that part of your life that is left. By the time you finished matric, if you live to the ripe age of 72, you have only lived 25% of your life. There's still 75% left, sir. So if your end goal is getting a matric mark, what after? You get my question. What are you going to do with the other 70% of your life? Ooh, I'm asking a bit of a nasty question here. But ladies and gentlemen, that's something you have to understand. Where you're sitting now, your end goal cannot be matric. That is a goal in your vision. My question today is, what are you going to do in the other 75%? What's your end goal? So everything I want you to think of today, and the rest of this time you've got in this exam preparation, this whole 2, 3, 4 days that you are spending with Dr. Klaasse and the JT team, your mindset must not be 18 or 19 years old. Your mindset should be, what can I learn today that is going to carry me through the 75% that's still left if I'm blessed to live till 72? That is your goal. So if I look at this, ladies and gentlemen, and I put it on purpose like this, as being your whole matric curriculum, understand that the examiner can ask anything on that board and you've got to know it off by heart. And let me share something with you. About 5, 6 years ago, I was at an AP Maths conference where I was a speaker and we had lots of fun. And one of the other speakers came from the University of Stellenbosch. And Dr. Klaasse, I think, will be able to verify what she said. What's a fallout rate for first years at university, sir?
What is that?
Fallout rate. In general.
It's more than 50%.
Get this? More than 50% of matriculants that made it to university do not make it through the first year. That's a scary statistic. And that professor, she studies mathematics and she teaches mathematics at the University of Stellenbosch. And she said one of the main reasons why people fail mathematics, more than 60% of first years fail calculus, is because, number one, the math toolbox is not full enough. Well, maths is not a study subject. I beg to differ. If I look at that board, there's a hell of a lot of studying that needs to go on in there. Secondly, the kids' toolboxes are not organized. In other words, when you come across a problem, you don't know, must I do this? Must I do that? Must I do that? And in the end, they just give up. Ladies, imagine you go and you want to go out for one evening and you want to be all dressed up. Let's say after for tonight and you guys want to go and have a drink somewhere. Hopefully not. And you just close your eyes and you grab into your makeup kit and you take the first thing and you just try and do your eyebrows with it. What's your chance of success? What do you say? Huh? Pretty low, right? Then why do you guys answer maths like that? Yes, sir.
What's an example of like perfect and full toolbox in terms of maths?
Perfect and full toolbox, thank you. We're going to get to examples and then I'll show you. A perfect and full toolbox for me is I come across an exponential equations. Example, I take exponential laws and equations. Exponential equations. I must know, with exponential equations, what kind of an exponential sum is it? Multiplication and division or addition and subtraction. If it's multiplication and division, I can apply law 1 and 2. My aim is to get the base the same, to isolate the base on both sides, make your bases the same. But what if I can't? Well, then I've got logarithms. But what if it is an addition and subtraction in exponential laws? Then I've got to think about factorization. After thinking about factorization, I've got to think about the zero product rule, which you use in quadratic equations. That's an example of being a full and organized toolbox. Because number one, I'm able to eliminate what I don't need from what I do need and only look at that. And that's what I'm about today. So I'm going to talk to you guys a little bit about that as well. Thank you for putting that on my radar, okay? So ladies and gentlemen, my challenge to you is you only have a month and a half left before you write matric finals. If you want to have success, your toolbox needs to be as full as possible. So how do I do that? Well, math summaries. How do I do that? I would get a bunch of buddies together. One Saturday morning, guys, let's tackle functions and graphs. Let's write down everything we know about functions and graphs. Take one Saturday and you do that. Why not? Remember, next year when you get to university, you guys see all these different blocks? They don't exist anymore. At varsity, they throw everything together. You do calculus together with financial mathematics. You do trigonometry with calculus. You do analytical geometry with calculus. Why not? We just don't ask it that way in the exams. So ladies and gents, our main aim in the end is for you to write a maths paper 1. So, what we are going to do today is we are going to practice a bit of mathematics. Okay, and I want to show you some techniques that I use when I need to prepare for mathematics. Okay, so we are going to tackle some amazing, interesting things, and throughout I'm going to give you some tips, I'm going to show you some awesome stuff. Are you guys ready for that? Okay, great. So what I'm going to do is, this is not in the handouts that I gave out to all of you, okay? I am going to give you a quick little sum that I prepared just about 10 minutes before we started today. Okay? There you are given the sketch of a graph. Okay, quickly draw it for yourself on a piece of paper. Okay, once you've drawn it, please put down your pens. Don't answer anything. You don't know what I'm going to ask you. Okay? It doesn't have to be an exact scale, so don't go and rub out, and it's not fine. Okay, now, we're going to do an exercise. Put your hands on your head. Everyone, hands on the head. Hands on the head. Okay, what do you see? Okay, someone, what do you see? Okay, so who said that? Okay, you. So what's your name? Alex. Alec. Sorry. Okay. Alec. Okay, so not like the lion. No, I saw that coming a mile away, right? So Alec, you say it is a graph. A graph. Okay, fantastic. What kind of a graph?
Which one?
The one that's drawn.
It's a derivative of the cubic.
Okay, so you're going already way too far. Let's take it a step back. What do you just see? A parabola. Okay, hands on the head. Hands on the head. Okay? There's a reason why I want you to go hands on the head. The first thing I want you to start doing when you are at home and you are analyzing a question is don't have a pen in your hand. Because then you guys want to answer the question. You want to just go and just write out the question. That's why putting your hands on the head. He says there's a parabola. And you already gave like half of it away. Okay? So now tell me, what else do you now see? There are X-intercepts. Okay? There are X-intercepts of a parabola. Why is that important? Yes. Help your friend out here. Okay, so now we are starting to do a lot of things. We are starting with a parabola, which is the derivative of a cubic function. Okay, very quickly there. Okay, and you've got X-intercepts, which are the turning point. Well done. Okay, why else do we need the X-intercepts of a parabola? Yes, sir. To determine the equation. Okay, now you can put hands down. Okay, so now what I want you to do is pick up a highlighter. Pick up a highlighter or just a color pen, not your blue pen. If you are like me and who's male, it only had a black and maybe blue and a pencil, then borrow from your friend next to you. Okay? Highlight the important parts on the graph that you can just see. So don't answer the question. Just highlight the important parts that you can see. Okay? So what important parts do I see? I see X-intercepts. What else do I see that's important? Okay? I see it as the derivative, which means what does that graph represent? Somebody tell me. Yes. The gradient of the cubic function. So in other words, the rate of change of the original f of x. Who sees something else that's very important on there? I see a turning point. What do I know about the turning point? What's your name? Yes. Okay, so we are talking about second derivatives to find the point of inflection. But what is the point of inflection in this graph? Or where would I find the point of inflection? Yes? Okay, the x-intercept of the turning point. X-intercept or x-value? X-value, yes. Be careful. Now, ladies and gents, here comes another thing. People ask me always, what's my secret to success? I am a pain in the neck when it comes to terminology I use, because x-intercept is different from x-value. Okay, x-intercept assumes y must be, but x-value means y could be anything. So how do I find the x-value of the turning point? Quickly tell me. But I don't have the first derivative even. Yes? Yeah. Ah, there we go. Very important thing. Okay, you find the center. Why is that? Because of symmetry. Is there any of you that are in an IB school, in other words, a private school? Please, the past 2, 3, 4 years, you couldn't answer questions about parabolas without thinking about symmetry. Every single year, they ask these weird applications and everything relies on symmetry. So this means this is at a half. Okay, so I've got the x-value of the turning point. Okay, that we don't know. How will f of x look? Now, some of you guys are going to draw it with your eyes closed. Why? Because your teacher showed you the shortcut. Okay? Not that a lot of you understand the shortcut, but they know. If it is like this, sir, the graph is definitely going to look like this. Okay? But why? It's just the way it is, okay? Am I right? Okay, please? If there's one thing you can take away from today, is don't stop questioning. Don't stop questioning. If you are not questioning why something is happening, you're not going to make a success at varsity. When I was at second year varsity and I studied actuarial sciences, woo, yeah, just name dropping, just, just quickly, I studied XI and then that's too boring for me, let me become a maths teacher. The professor in Calculus 2, an amazing professor, he stopped us halfway through, and we were about bigger than you guys, bigger size than this group. Full of XI students who, like myself, at the bottom range had about 3 distinctions in matric, and at the top range had about 16 distinctions in matric. Okay, I'm not joking, really, 1, 6, 16. And he looked at us with very earnestness and he asked us a question, why are you able to do this? And we looked at him and went, our teacher showed it to us, therefore we've got to use it. And he said, well, then you can't use it at all. If you can't give me a valid reason why you can apply a formula, you're not allowed to use it. So I want to ask you this question. How much of your matric maths knowledge can you then actually use? That's your own question to answer. Okay, I can't answer that for you. How much of you really understand why? Or actually question, but why? Yeah, let's leave it there. Okay. Why does this graph look like that? Why? Let's start with why is it a cubic function? Why is f of x a cubic function? Okay, now you might say, sir, but it's written there. which is very astute from an observational point of view. But how do I know this? Because logic tells me if I've got y equal to x to the 3, and I derive this, I get x to the power of 2. Okay? Same thing applies with if I derive it again, I'm going to get x to the power of 1, which means your second order derivative is a straight line. Okay? So, the first thing that you've got to be able to do, yes?
What if I say a graph is a certain graph due to its height of an exponent?
Okay, I like where you're going. So, when it comes to polynomial graphs, I agree 100% with you. So what she's saying is, can I say what type of graph it is depending on the degree of the polynomial? 100% right. 100% right. The problem comes in with what if I have other types of graph at varsity specifically? Because at varsity level, we are going to look at ovals, we're going to look at ellipses, circles, all of those. Then it becomes about more than just the degree. But at school level, I agree with you. Okay? 100%. Your degree tells you what kind of graph it is, as long as it's a polynomial. Okay? So let's look at that. Let's interpret. Because again, ladies and gentlemen, I can be a pain in the patella, okay? And ask you the following. +1 and 3, sketch the original function if this is the derivative. I can ask it of you. And my students call it a Mr. VG special. Okay, even though I have never asked it, they'll call it that because it's not really difficult. It really isn't, if you understand it. So how do I analyze something like this? I start with the most obvious. So how would I draw this? That's the question. How would I draw the original? Let's start with the obvious things. What is the X-intercepts? So look at the way I analyze a question like this. That's my X-intercept, which means what? Y is equal to 0. But what does Y represent in this case? Y is the first derivative, okay? When is the first derivative 0? What does it tell me of the original graph? It gives me the? Be careful of the word. Not turning points, but stationary points. Okay, so stationary points. So in other words, this is the stationary points of f of x. Everyone's all right with that. So I've got 3 stationary points. X equal to -3, 1, and 3. So those are my stationary points. Where's the y values? Positive and negative. That's now a very important question. Let's start on the left-hand side of -3. Is the y values positive or negative? I'm talking about, for some of you who's getting confused between left and right, I'm talking about that part there. Is my y values positive or negative? Where else is the y values negative? Between 1 and? So everywhere there with the green, y is smaller than 0. But what does y represent? What does y represent? The derivative, right, sir? And where is the derivative smaller than naught? What does it tell me about the original graph? Come on. What does your theory say? What's in your toolbox? If first derivative is smaller than naught. Come, matriculants.
The gradient of the graph is negative as well.
Which means the graph is? Whoa, be careful. Increasing or decreasing? Decreasing. Please, ladies and gentlemen, remember, and I'm saying this with something very important, you've got to understand the difference between what fx, f accent x, and f double accent x gives you. Look at the way I analyze it. So there's now two intervals where my graph is decreasing. Everyone's all right with that? Which means, where's my graph increasing? Between negative there and there, my y values are positive, but y is actually f accent x, and therefore f is increasing. So therefore, if I have to now sketch the graph, where do I start? Where do I start? Okay, I start with my turning points, or my stationary points. My stationary points are at -3, 1, and 3. So in other words, in my new graph, okay, sorry, there we go. At -3, I have a stationary point. At 1, I've got a stationary point. And at 3, I've got a stationary point. Everyone's all right with that? On the left-hand side of -3, my graph is increasing or decreasing? Okay? Decreasing. So in other words, my graph is going down. Between 1 and 3, my graph is going? Between 1 and 3. And now between -1 and 3, it's increasing. So looking forward there, my graph is increasing there. It's increasing there again. On the right-hand side of 3. So how does my graph look? Down, turns, up, turns, turns. There, ladies and gents, you have a very, very rough sketch of y equal f of x. Have you ever drawn something like this? Yes. You are most welcome to.
Why is it going below the -3 if it's an x-intercept?
Please be careful. At -3, it's not an x-intercept. Okay, so she's asking, why is this one going below? Well, let me ask you this. Is there actually anything making this graph turn on there? No. It could turn up there. Do we know where it turns? I'm talking about the y value where it turns. Come on, matriculants, you guys are like, I don't know what you're asking, sir. Does it turn there? Does it turn there? Does it turn there? Do we know? No, we don't. That's why the instruction was draw a rough sketch. I never said an on-scale sketch. So how would the examiner give marks? Where does it turn? Where's your graphs increasing and decreasing? The shape of the graph, 3, maybe 4 marks. Can they ask this? Hell yes. Why not? If you've written IEB exam papers, you will know they can ask anything. And they love to ask anything and everything. So, I went down a rabbit hole there. I think next year I'm glad I'm not teaching matrics at my school, because then this question paper would have been in the exam. But I might, as a moderator, go and say, ooh, let's put this in just for the fun of it. I'm that kind of a teacher. Okay? Now, ladies and gentlemen, any questions about this one specifically? Any questions, ladies and gents? Okay, so let's get back to the question I actually wanted to ask. I'm going to give you 5 minutes quickly. You can work together as mates. I'm looking for 2 things from you. Number 1, I want you to sketch the second order derivative. Secondly, I want you to determine the values of A and B. Not other way around. First, sketch the second order derivative. Secondly, I want you to determine the values of A and B. And if you do further study mathematics, you are not allowed to use integration. Okay? Okay? Go for it, ladies and gentlemen. Have fun. I'll give you what? Let's make it 10 minutes. Ladies and gents, I understand that you've got amazing teachers. Really, I do. But next year, you will not necessarily know. So the big thing that I want you to do is answer questions by actually thinking about it. Why is this graph here, the y values smaller than 0? Why is it like that? That's what you've got to start answering yourself. Okay, now, it's been proven, and I'm saying this, it's been proven by looking at huge statistics. They took students from all over the world, and they compared the students from the different countries writing an international exam. South Africa eventually stopped the international exams because we kept coming last. Really, that's what happened. Eventually, we stopped writing it because they just said, nah, we know where we're going. But they compared and they came to the realization that schools that are taught tips and tricks and techniques every year do worse than schools where the focus is on theory. Every year. Because if I ask you something that's just outside of the theory, your tips and techniques, and you don't know the theory, you are going to fail because you've only practiced the previous year's exams. So please, I encourage you for the next 75% of your life, I guarantee it, and I want to speak to my friend here who's a dad now 3 times over, okay? Are there any manuals that comes with those 3 kids?
Not ones you can trust.
Not ones you can trust. And every manual tells you something different. Yep. And every manual will tell you the other manual is lying. That's the truth. Okay, I'm a father myself. I can't rely on tips and tricks and techniques. But what I want to go down a rabbit hole for a moment, ladies and gentlemen, is the following. By the time that you hit 30, that's just 12 years from now. Absolutely none of you or none of us have any cooking clue what the job market is going to look like. We don't know what jobs are going to be out there. Your degree that you're going to study, by the time you finish studying it, is already going to be outdated. Hashtag just saying. I'm painting you a picture, but it's realities. 5 years ago, Chris knows this guy, studied at Hatfield Christian School with us, or he was one of my matriculants, laziest son of a gun that I've worked with, okay? Always got in the 50s, never got above it. He could get in the 70s and 80s. By the time he finished matric, year after that I saw him. I'm like, so what's he been doing with your life? Now I'm sitting at home in my pajamas and doing website development for international companies. I'm like, ah. And then after that, now I became an esports commentator. I travel throughout the world. They put me on planes. I've got a professional stylist that's doing my hair, so that's why my hair is so messy, because I didn't have my stylist this morning. I'm looking at this guy and going, so you're literally telling us how other guys are playing computer games? Yeah, I go all over the world, and when I was in matric, which is 20 years ago, I'm feeling old when I say that, 20 years ago, that was not even there. If I had to tell my parents that I'm going to go and tell other people how people play computer games, they would have just laughed at me. But that guy made more money than I can make in a year. He'll make in a few hours. What's going to be out there for you? We don't know. So you cannot just rely even on your teachers to show you the tips and tricks. You've got to understand the work, because that you can build on in your future. So if I look at this, what is the understanding that goes into this? Yes, sorry, you've got a question. Yes, please.
So we see that from x is less than 1 over 2.
Yes.
It's like the gradient is negative.
Okay, so my graph is decreasing, you're right. Now, I like it. Let's look at the maths behind it. How do I write the gradient of this graph, of any graph? What do I do to get the gradient at a point? Okay, that is gradient between 2 points. But at a point, what do I do? Okay, just the derivative. So if I take the derivative of y, it becomes f double accent of x. And this is smaller than naught. Which means if this is now f double accent of x, it has to be smaller than 0, because it's decreasing all the way to there. Okay, that's your understanding. I like it. Well done. But now what on the right-hand side of a half? Now my gradient increases. How do I write the second order derivative if I've got y? Remember, I go y is equal to whatever. Then I derive once, and it's dy over dx. What if I derive twice? How do I write that? D squared y over dx squared. How many of you knew that? So you've got to look out for it, because they can ask it of you. Okay, d squared y over dx squared. You've got to understand that that means second order derivative. If you've never seen it, now you can make notes of it. Okay, now you can make notes of it. Okay? So third order derivative would be d cubed y over dx cubed. I would love to one day one of you explain to me why that is. But we'll leave that for another day. So how would I get the values of A and B? How would I get that without integration? So what do you say? You, yes, you. Yes, you. What's your name, sir? Ray. Great, Ray. My main man, Ray. Okay. You can if you want to. Okay, how would you use the second order derivative graph to give me the value of A and B? Okay, I like that. So first order derivative is just x squared, right? Plus 2ax plus b. And if I derive it again, I get 2x plus 2a. And then what did you do? The half into x and? Okay. But let me ask you guys this. How many of you did something similar, or you used the first order derivative and solved simultaneously? Who solved simultaneously? Be honest. Okay, what did the rest of you do? Yes. Oh, well, you're on point today. What's your name? Retabile. Okay, Retabile, what did you do?
Okay, so I got the first derivative, right?
Yes.
And then we know that those are the turning points.
Okay, yeah.
Yes, and then I use the turning point formula for parabola.
X equal to negative b over 2a.
I said a x minus 2 and then x plus 2 and then the other bracket x minus 3.
Okay. I like where you're going. Ladies and gents, you are all a bunch of sheep. Those of you that use simultaneous equations. I'm saying it with a lot of love in my heart. Why do I say that? Because what do your teachers say? Plug in and solve. If you don't know what to do, plug stuff in and solve. How many of you determined the equation of the parabola? Okay, and then what? So what is the formula for the parabola here? Y equal to, let's quickly write it down, 1 x plus 2 x minus 3. Everyone's all right with that? How did I get that so quickly? Yes.
Well, your graph is positive, therefore it means your A on that equation should be a positive 1. Yes. And then those two, x plus 2, x minus 3, your 2 is a negative, so when you put it inside the bracket, it should be 2, and then
I like it.
positive, so it was going to be negative.
So in other words, what she's saying is, I can read off the 1 because there's a 1 in front of the x squared. This plus 2 is from being an X-intercept there, and the 3 because it is the other X-intercept. Now let's multiply this out. X squared minus x minus 6. Everyone's all right with that? Now let's quickly compare it to the derivative that you got at the beginning. F accent x is x squared plus 2ax plus b. Now let me quickly show you. Dirty little school trick. Those must be the same. That must be the same. B is 6. 2a must be negative 1. That's how simple and easy it is. Did I have to do simultaneous equations? Not at all. Is it wrong? No. It's not wrong. But ladies and gentlemen, how many of you are aiming for your 90s, 80s and 90s? Be honest. How many of you are, okay, realistically aiming for 80s and 90s? Okay? Let me give you a challenge. Every single sum you do from now on, you have to find 2 alternatives how to do it. Because you don't know what the examiner is going to ask. So you cannot just do it the way your teacher showed it. Because you don't know what the examiner is going to ask. So find at least one alternative for every single sum you do from now on. So if you just want to run like a bull in a china shop, I'll get to you now. Be careful, you don't know what your examiner is going to ask. So find an alternative. There's always more than one way. I've marked matric exams. There's like 10, 12 ways sometimes.